Okay, so what is it all about, Alfie, right? This course itself? Well, in a sense, it builds on what we did together last term. And actually, you're going to notice a lot of things look very much the same with these new projects that we're going to do. As I say here, it's similar to the MVC design pattern that we were using without the V, right? So leave out one of the letters, you might say, okay? We're still working with models. We're still going to have controllers, although they're based on a different class than the controllers we were using last time. But we're really just sending data, raw data, so to speak, back and forth over the internet, right? And this has become ubiquitous, this approach to software development these days, because that's what the internet is, in my opinion, almost best for. I mean, you leave your web pages to when you're bored and you want to sit and read something, but you know, in terms of a productive application, working with a business client and so on, what they need is to get the data into a central repository. And there's nothing out there better than the internet to provide that, right? You can have the good secure connections, everything else that you really need. So the question is, okay, well, what's going to be on the client? If all you're sending is data back and forth, right? We're going to be focusing first of all on the server side of things with our WebAPI applications, and it opens it up. You can have any kind of client just about out there, right? We'll work with a web API. We'll work with just a good, secure data source. So it could be a mobile application, something, you know, written in Android Studio to run on an Android phone. It could be something on a tablet, on a PC. It could be even through a browser still, right? That's all perfectly fine. Dedicated PC applications and so on, they'll all work with the data coming through our web API, right? So we're going to talk more about this in detail, but I'll just introduce this term, Representational State Transfer. REST is the architecture. There's been a history, there's been refinements on how we approach this, and this is so much simpler than what we often used to do, and it just works very, very well. So that's kind of the first part of the course, right? So if we come into the content here, I should just, as we always do, talk a little bit about the TLP, right, the teaching learning plan. Now this is a fairly succinct one. It's not quite, oh, wants me to open it. Oh, darn. I'll have to sign my life away to Adobe again. Okay. That's okay. It'll come up and bug me in a moment here, I'm sure. Yep, there we go. Sign my life away. Okay. All right, I've really just given you in terms of a schedule here. These are the weeks where they're the main evaluations are happening. We'll talk more about the arrangement of the evaluations and so on, but it also kind of gives you an overall look at the flow of the course. We're starting off with this web API, these RESTful web services, and then we'll look at least one or two different types of mobile clients for it. And then around break time, more or less, or a little bit before and after, right? What we're going to do is we're going to completely switch gears for a little while. Give our brain a rest from all that design pattern approach and do something that's important to cover before you graduate. And we've never really had opportunity to take time and just talk about unit testing. Unit testing, I guarantee you're going to be spending a lot of time in your professional career if you're working for anybody else doing unit testing. These days, it's about the only way to try and develop any kind of a complex application without introducing a gazillion bugs, right? Bugs are easy to do. We've all done, you've seen me introduce bugs in my demonstrations because I leave out a comma or, you know, have the wrong verb somewhere or something like that, right? We all make those little mistakes as we're developing. So how do we catch them and make sure that as changes happen over time to our application, that we don't introduce new issues, that maybe something that isn't just a syntax error, but a logical error that works fine in isolation in the one area that we're working, but maybe there's a domino effect and it affects something else in the application somewhere, right? So we'll do a whole dedicated module on unit testing and how we can incorporate that. I can tell you it's going to be fairly basic and introductory, right? Because there's a lot to learn about unit testing as well. It's a very important area of software development going forward. It's also some of the most boring kind of programming to do, to be perfectly honest. But hey, it's important nonetheless. So we'll do a module on that. And then we're going to come back and work more on putting it all together, right? Doing the work with Web API, mobile, and unit testing, combining it all into a final project there as well. Oh, sorry, a final test as well. All right. So as I say, schedule's got to remain a little bit flexible because we're often modifying things, especially if there's something relevant to do here related to your project course as well. AI, okay, I'm not going to be so opposed to using it this time around. Just please document it. I have the form up there in Brightspace. So if you use AI, just report it, and then we won't have any issues with that whatsoever, right? Okay. Final grade is the standard approach now that we've been adopting across all of our courses, as you've seen, right? Basically, the weighted test average has to be above 60% before your lab marks can raise your final grade, right? Okay. There's no other way to raise them. There's no separate makeup evaluation, so please do all the work during the term and get it handed in, and we're good to go, okay? As usual, I don't ask you to sign documents. I just say, hey, if you're still in the course after day 10, then you agree to the TLP, right? And that's basically all there is to it. Any questions about the TLP? I'll talk more about these assignments and so on in a few moments. Okay. And the only other thing I'll point out up here, here's that artificial intelligence usage record, okay? So just, fill this out, put, what you did, and so on and so forth. And you've used this in other courses, so there's nothing too surprising. Just hand that in with the work when you hand it in. All right, let's get into the weekly content. So what I have up so far is just our first week here, introducing Web API. Okay, we'll actually today hopefully get to do at least a little bit of playing around with a client application. And then I have my first major demo. Now, of course, that's what we did on Wednesday, is we kind of went through step 1 here, right? So I'm thinking if we get time, and we should have time today, because it doesn't take too long to get through this introductory stuff, is we might actually just jump right ahead and do step 2 together. And if I get a good recording, great. If I don't, I have one more section to do this afternoon, and so that should get that all done and taken care of as well. So that's kind of our agenda for today, but I have these PowerPoints that kind of go into a bit more detail, and then I should take time to share with you. So any quick questions before I start the first PowerPoint? Fair enough. Okay. All right. And, I have to sign my life away. I just have to accept the agreement here. Good. Okay, and that's mostly what it's about, Web API and Web API client, right? So as we kind of already mentioned, Web API is like a data-only version of MVC, okay? Implementing RESTful web services, more to come on that shortly. And we'll see how that works well with mobile application development. You did some great work with Peter last term, right, using Maui as a particular mobile application tool. And you did a little bit of work with a local database, I believe, a SQLite database on the device, right? But we're going to see how we can now take that same kind of development and work with perhaps a much larger database connecting through the internet itself, right? And we'll explore a few different client apps. Okay, we'll definitely do console clients. We might even get that done today. We'll look at Maui. We'll look at Windows Presentation Foundation maybe, or Windows Communication Foundation. We'll look at a few different ones. Maybe even we'll get Blazor in here. It's hard to say. Unit testing. Okay, so that's the other thing. Basic unit testing, test-driven development. That's another thing that this course will cover as well. You saw in the TLP there that we have 3 tests, 2 projects, and homework exercises, right? So test 1 is really all about that RESTful web service, that design pattern that we're implementing as we do our Web API, and that's a 20% weight, okay? We'll have a smaller test in the middle of the course there on our unit testing module, right? And then our final test is worth another 20%, and that is on the combination with both Web API and at least some kind of a client. Last time around, I gave you a choice. You could do any type of the clients we looked at as for your Web API, and there's a unit testing component in that test as well. So that's half the final grade, 50%. The other 50% comes from the 2 projects. So project 1, okay, is based on Web API, right, with a client. Project 2, what I like to do in this class, right? For some of you, you're graduating after term 4. Some of you are coming back for, the analyst portion, right? The co-op and then the final academic term. So at this point, I like to throw this project open. What I'm going to do is I'll have 2 or 3 canned project ideas that you can choose from to do for project 2. But if you have something that you've been playing with on your own, or you have an interest in, right, then I'm going to as well, and I'll get the instructions on how to put your project proposal together. You can submit a proposal that says, I'd like to do a project on this, right? And I rarely say no, right? But what I sometimes say is, you know what, I think that's too big. You better scale down the scope. It's a bit too ambitious to fit in, because I know how you're going to be, busy you're going to be this term with not only this course, but all your other courses and that humongous community-sponsored project course as well. So, but yeah, I've had all kinds of really interesting projects proposed and beautiful work done. Everything from some games, right, to all kinds of weird applications. If you do something that I've never taught that kind of coding before, then I cannot help you too much with it, but hey, you can show it to us, right? And there's time at the end of the course to actually demonstrate your project as well to the class for a few extra grades, right? Things like that. So yeah, it's actually quite interesting that students often get quite excited about the idea of being able to develop a project in a tool that they've maybe had some history with or some interest in, something that they want to really have a chance to explore, right? Or you can do one of the canned ones that I'm going to propose. Any questions about that project 2? All right. Okay. So just into the logistics. So all the tests will be open book. Now, when I say book, I'm physically mean to be consistent with how the other faculty like to do the tests. I don't mean online, although I will always give you an example of a working application that you can use to reference, like I did with the MVC, right, when you were doing that last term in the test, okay? Hands-on performance tests, right? There's no theory tests in this course. And the other thing I mentioned earlier is we'll have homework exercises. Now, these are for you to have something to practice with, because we all need to be able to practice, right? You don't hand the homework exercises in. They are not evaluated. You don't get a grade for them, right? They'll be there so you have something to use to prepare for the test, to prepare for the other work that you're going to do. So they're not submitted for evaluation. Okay, quite often I'll even post the solution right along with the instructions. That way, if you find you're stuck at some point, you can peek, if you want to, at the solution. Just forget, oh, okay, that's where I was making a mistake. Go back and then finish the exercise on your own, right? Sometimes I withhold the solution, if it's a really simple one, until everyone's had a chance to try it on their own first, right? And as time allows, we'll take them up in class, right? But they're really there for you to, on your own then, because you're adult. It's adult education, right? Not everything has to be tied to a mark that you hand in. Just give you something to practice with. Final grade, this is just right out of the TLP. I don't have to spend time going over this again. Same things, no provision to raise your final grade above, and there's no makeup tests or separate evaluations. All right, so as we get started then, I've mentioned it a few times about the Web API being just like MVC without the views, okay? And we'll talk more about that further going on. We're focusing on the latest iteration of Web API, which is using RESTful web services. We'll talk a bit more about the history and so on of it later on. But Roy Fielding, okay, he is one individual who, it was actually his PhD thesis. He wrote his thesis on this concept of the RESTful web service, right? The Representational State Transfer approach, right? And ever since then, it's just caught on like wildfire because it's just so simple, elegant, and effective. And it reduces so much the work involved in getting something like a web service up and running, right? And we'll talk more about the details of this in our later discussions, right? But basically, we can just send data. Now, the data can be in any kind of format. It could be straight text. It could be JSON format, XML. Okay, JSON is the most popular. There's other ones out there. There's AtomPub and different things that you can use as well. But, you know, we're basically going to just get along and work with it. Right? Okay. So a little bit more in detail then in this next PowerPoint kind of repetitive. I should have taken time to remove a little bit of material out of this duplicated here, but I don't think it'll hurt just going through it as it is. So a little bit more in-depth then on what this web API is and the history behind it, right? As we know, let's face it, the internet is now one of the most common things. Who doesn't use the internet just about every day? In North America, in much of the world, right? It's everywhere, okay? So HTTP is, you know, believe it or not, I went to school when there was no such thing. And many of us did, okay? Now, just about every platform out there has some kind of client that can work with HTTP. Now, we get confused sometimes thinking HTTP, that the internet is a web browser and HTML markup pages. No, many years it was strictly data, right? Or text, you know, being sent back and forth. Then they came along with browsers and things like that. But our web API services we're going to create, they work fine with browsers, any kind of mobile device on the planet, desktop applications, you name it, can all be a client for our web API, right? Many of these platforms will also allow local storage as well. So that's where you can get into what we often used to call, and I used to teach, occasionally disconnected applications, where if you lose the internet connection, you can keep on working, adding records, editing records, and so on. And when you get reconnected to the internet, because you're in a different spot now and you can reconnect, then you can synchronize all your changes back and forth and so on. You know what? These days, it's become less important. Can you guess why? Because of how widely available the internet is now, right? So yeah, it's great if you can do that too, and that's important in some situations, but it's really not the focus anymore, right? Okay, anyway. I do like to give you an idea of the history of things. So XML web services date back to the late 90s, right? There was mostly verbose text using XML. They had the SOAP, Simple Object Access Protocol, was one of the first international standardizations to allow this data transformation, or transmission, I should say, across the internet, right? And along with that came Web Service Description Language, right? So that used to be, we have to write all this documentation basically to tell the world, if you want to talk to my data source, here's what you have to do. These are the rules on how you talk to my data, right? And that was all done through the WSDL and so on, right? And that worked. It worked well in the early 2000s and so on, and it was very popular. Visual Studio came out in 2008 with Windows Communication Foundation, which was largely built on that, but then streamlined the process. And at the same time, they added .NET remoting. So instead of being verbose text going back and forth, it allowed for the first time a digital format of data transfer, right, happening in the same way, right? So .NET remoting brought that along. Then later on came RIA, REST, and Open Data, okay, as all new standards. So we already talked about REST. That was the one guy who did that as his PhD thesis, right? So now we've brought all the best of the parts of all these approaches and technologies into what we're now doing in, as we call it, Web API, right? So what that guy did, it was just so clever. HTTP as a standard had always had a whole bunch of different verbs built in to the standard. You know some of them. You know this first one, get, right? We've talked a lot about get requests, and the next one, post requests, and so on. So what this guy did is he thought, you know what? Let's see if we can correlate these verbs to the CRUD operations that we normally think about when we think of a database, right? CRUD, create, read, update, delete. Those four operations, which in SQL terms are select, okay, create, you know the rest. Okay, all right, so he said, well, let's use the get verb for selecting. So right in a simple URI, we can go and we can select data, okay? Basically form a select statement as part of the URI. We'll use the post verb for inserting records, all right? So we can insert, basically just bundle up the data. We know it goes as part of the post request. We put the data in the body of the request. The URI itself contains the necessary information to know, okay, what this data is for. Put. Has anyone been aware that there was a put verb in HTTP? And it's been there from the early days of the standard, right? So he said, let's use that for doing an update, right? And I'll mention now that there's actually two different styles of a put, right? The most common and easy one to do is basically you say, here's a new complete version of the record. Put it in place, right? And that's the easiest one to do. Later on, time allowing, we'll also look at a more succinct version where you say, well, out of the 15 properties of this object or record, whichever way you want to think of it, object-oriented or database-oriented, right? We've only changed one thing. So rather than send you an object with all 15 and we only change one, we can just send, hey, this is the field that we changed, right? And that can be done with a put as well. This was a no-brainer, okay? There was an actual verb in the HTTP standard called delete, okay? So that was a pretty straightforward one. So that's all we did, is he lined up these, okay? And I have a note there at the bottom that there are other verbs that aren't even used as part of this, okay? There's head, patch, options. That pretty much covers all the verbs in the standard. Get, post, put, delete, head, patch, options, right? Okay. So that actually is how you get the data back and forth. But that's not quite the end of the story. You have to decide how are you going to bundle the data or represent the information, okay? And that's where the two most common formats used are JSON, JavaScript Object Notation, which we've all used before, and of course XML, which you've used as well, right? XML, of course, HTML itself is a subset of XML, right? So is, of course, the XAML that we use in our mobile development and so on that you've been doing for both Universal Windows Platform applications and MAUI applications and Windows Communication Foundation and so on and so forth, right? And there's a few other out there. I mentioned AtomPub earlier, just form URL encoded data and so on and so forth, right? So there's lots of choices out there. By far, the most common is JSON. One reason is there's every client out there, every platform out there has a client that supports JSON, right? And it's more succinct. There's fewer characters involved in sending data with JSON than XML, because XML, the strict definition requires an open and closing tag around everything. And sometimes those tags take up more room, more characters than the data itself that goes between them, right? So JSON is more succinct. But of course, that's just for textual data, right? But we want to be able to work with other things. Where did we use MIME types last term? Yeah, when we uploaded and downloaded all kinds of things. Images, Excel spreadsheets, Word documents, and so on, right? That's where MIME types come in. And sure enough, we want to be able to do that as well, right? So we use media formatters along with, okay, our web API, our web services as well, right? And of course, model binding. We're going to use that. We used that extensively last term. That's what allowed us to, basically just send information about all the properties of an object up, okay, in our post, for example, right? And right in the opening line of the post action, right, it would just say, here, take all this data and make a patient or a doctor or whatever, right? We could build our objects. Well, believe me, in the old days where I did a lot of my programming, you had to manually take every piece of information, assign it to the property in code one at a time, and do all that yourself manually. But now with model binding, okay, it just becomes an automatic process for us. It says, okay, I can take all that and build you whatever you want, right? So we're going to materialize our entity objects very easily. And at the same time, of course, we're still going to take advantage of all those great data annotations, right, that allowed us to do things like simple validation and so on and so forth, describe the relationships between objects and things like that. So that all gets used as well. But one of the big issues that we run into with WebAPI, which was not a problem for us with MVC, and basically that's because we didn't serialize the data, right, is circular references. Okay. So it does integrate beautifully with MVC, but, okay, if we're going to create our data annotations and everything else the same way we did and our properties to have the relationships in place with our model objects the way we did with MVC, we're going to run into a problem, right? When we serialize data, okay, what happens is it goes in, looks at the data, okay, builds out all the JSON for each property as we find it, and then it follows the path that we've defined by our relationships. So for example, think about the, well, again, I'll use patient and doctor, right? So doctor's the parent in the relationship, patient's the child in a one-to-many relationship. Remember the properties that define that relationship. In the child, we have a copy of the patient object, the doctor. For our convenience, we usually always include the primary key value of the doctor as well. If we're using an integer identity, then it's an integer. If we're using a GUID, it would be a GUID, right? Whatever the primary key of the parent is, okay? And we put those in the child. In the parent, we would put that I collection of the child objects, that I collection of patients. And that was how we set up the relationship, and it allowed us to do all kinds of beautiful things like dot include and so on and so forth, right? Problem is, right, having those in there, when we go to serialize this into JSON or XML or anything else, okay, the serialization process, think about it. So if we have a dot include, right, for the doctor, so the doctor object is included in the patient, well, it goes through it, serialize, okay, the first name, last name, etc., down through, then it hits the doctor, okay, we'll serialize the doctor. So it goes and gets the doctor, serializes the doctor's first name, middle name, last name, whatever. Oh, here's an I collection of patients. Okay, we'll serialize that. Goes into the collection of patients for the doctor. And then, of course, when it hits the doctor for the patient, and then the patient for the doctor, and goes around and around and around, right? So eventually it'll detect what's called a circular reference, and after 32 times around the circle, okay, that's the default setting, it'll stop. Say, there's an error, we have a circular reference, right? So that's the problem that you run into, right? The parent object contains the collection of the child, and so on and so forth. So how do we handle these circular references? Well, we have to have that reference to the parent object in the child to make the foreign key work. That's required. So a lot of the introductory tutorials on WebAPI, they're lazy. They avoid this altogether. They just leave out the I collection in the parent. They don't have the collection of child objects, right? And that way, it's not a problem. They just ignore it, right? And they leave you to find out about the problem later on, okay? So that's really not the best solution, though, because in the real world, we want to have that. We want to be able to do a dot include to include that related child collection, right? Okay. So don't just take it out. What we can do, we want to be able to do a dot include, so oh, yeah, that's just saying that many of them leave out the collection from the parent. There's a few different approaches, okay? And actually in the demo I recorded on Wednesday, if you take time to look at that now that we've had this discussion, you'll see I kind of walk through and show you a couple of them. But basically the JSON ignore, it's in a slightly different namespace, but it's easy to add. We can put that on anything that we want to say, hey, stop here. Don't serialize this, right? So typically we can put that on the I collection of the child objects inside the parent class. And that stops the circular, right? It prevents it from chasing its own tail round and around and around, and then we don't get those errors anymore. So that's a quick, simple fix, right? And since it only affects serialization, if we're using, and by the way, that's something we will introduce later on, we can have in a web API, we can still have MVC controllers. In an MVC application, you can have web API controllers. They're so compatible, they can just combine both and have both kinds of controllers in the same application, right? So that's why we don't want to take out, okay, the I collections of child objects inside of the parent, because we might want to use that so that we can do a dot include with an MVC controller, for example. But this solves the problem for us using JSON ignore, right? Now I just want to note here, as it says at the bottom, this is not the only fix we have available. And in my copy-paste file for the first step 1 demo, you see I have in there some of the other ones that you can use. I didn't actually even take time to show them the other day. I will at some point, just so you see them in operation, because it's kind of interesting to see what they do. But in the end, we aren't going to use any of these solutions. We're going to use something else that solves this problem and another equally, if not more important problem as time goes on, and that is to use data transfer objects, right? So you say, why am I taking time to talk about all this? Well, you have to be aware of this and know why, one of the reasons why we're using DTOs in the first place. Okay? All right. A little bit of talk about the JSON libraries themselves. Because we're using JSON, there's a library. How many people have noticed, because I know you've used it, have you noticed that you've been using Newtonsoft JSON? Okay. It's not a Microsoft thing. It's international. It's been around forever and ever, right, since the early days of JSON itself, okay? Newtonsoft JSON is a library of tools for working with JSON. There's a .NET package that easily lets you install it, okay? But it's not just a Microsoft thing. Let me emphasize that, okay? And it still works. It still does everything we need it to do. But because it's been around for many, many years, clever developers have added more and more power to it, right? But at the same time, it's gotten bigger, heavier, and bulkier, right? And a little bit slower as a result as well, right? So we have a new JavaScript, or JSON library, I should say, JSON library, that's available to us. It was introduced with .NET Core 3.1, right? Now, of course, we're up to using .NET Core 8 right now. We don't even say Core anymore. We just say .NET 8, okay? There's no NuGet package required because it's fully integrated into .NET, okay? It's standards compliant. One of the main things here, better performance and better security than Newtonsoft, right? There are some limitations because it's new, okay? It hasn't had as many features added to it as Newtonsoft has, right? Bottom line, it doesn't matter really which one you use. You'll get better performance using System Text JSON. And in our Web API, that is what we will use. But you'll be interested to see that when we create certain types of client applications, you'll be using Newtonsoft. It doesn't matter. In between the server and the client, the only thing I have going back and forth is the JSON itself. What library you use to process that JSON at either end doesn't matter, right? They both work, okay? So in many clients, we'll still be using Newtonsoft, but on the server, we use this newer, more performant system.text.json. Okay. So yeah, I'm just mentioning that as well because in some tutorials you'll find online, you'll see it talking about data contract and data member. Okay, those were part of the annotations to work with the Newtonsoft JSON that we don't really need to worry about anymore. All right, so that basically finishes our discussion to introduce. Let me just talk about here, I have this, your first homework assignment really is this tutorial, right? Create a web API with ASP.NET Core. So it's kind of like I had that first tutorial for MVC I asked everyone to work through, right? It's pretty self-explanatory. You go through, you create a simple model class, a data context, and so on. You scaffold a controller, you get it up and running. Oh, and here's the, as long as you don't uncheck it, as you create the project, it includes this Swagger interface, right? One of the problems with having a web API is it because there's only text, right? It's pretty awkward to work with, right? So by default, we install this little tool here, Open API, I think it's called. And anyway, it presents itself as Swagger. And it gives us a nice user interface on something else that normally there is no user interface for, right? So if you please watch my recording from Wednesday, I go through and I demonstrate a fair bit of how we can use. It gives you all access to all the verbs that you've implemented. So if you have a put and a push and so on and a delete, you can actually use this interface to actually insert, update, and delete records, right? Even without a separate client application. So it's great for doing some testing to make sure your web API actually works, right? But of course, you don't actually use it in the real world, right? When you actually use your web API, you bypass that altogether. Okay, so it's just a simple to-do item and so on and so forth. You'll get down to a certain point where you're done the main tutorial. Okay, basically here where we say add authentication, I say basically stop at this point in time, that's explained, and then go on to this tutorial, okay? And then we're going to create a JavaScript one and a client using JavaScript, right? So that's an example of another type of client, just a web browser using JavaScript, right? And so go on to that one, okay? So it's not required for you to continue to the add authentication, because that's something we're going to revisit later on in the course with a slightly different approach anyway. All right, so that's your main homework to do, but I also have for your practice, okay, step 1 and 2 of the demo. So I recorded step 1 the other day in our 1-hour class together. If you're game for it, I'll do step 2 after we have a break, right? Homework. Before I end up my recording here, I'll point out I have released my first practice exercise. Remember, you don't hand these in, and so you have something to do, right? So you have something to practice with to reinforce your own learning. So what you're going to do is you're going to create a web API for artwork and art type. Have I used these classes with you before? I use it in a lot of my other courses for demos, and some of the other faculty uses it sometimes. Anyway, it's a simple one-to-many again. You have different types of art, painting versus sculpture versus whatever, right? And then you have artworks that are one type of art, right? So it's just another set of models to work with. So I've got some model classes for you to start with, and I have a little bit of seed data, okay, that you can use. So, you know, paintings, drawing, sculpture, and then a few artworks that you can just code in as well, right? So basically just take these model classes and build a web API. You can just follow the demo example, right, and do it the same way, but it'll give you a chance to practice, and then we'll use it in the next practice exercise as well. All right? So that's it. We'll stop recording at this point.